Thank you very much.
Okay, so I'll open it up to questions on the review. If there's any of these you'd like to go over, let me know. Nine, okay. Let's look at number 9 here. It says find the divergence and curl of the vector field. Okay. So let's do number 9 first. Okay, so we have, yeah, that's fine. Go ahead, Hong. Okay, so we have f is equal to, this is number 9, cosine zi plus 3y sine 3zj plus 6x cubed zk. Okay, so I want to find the divergence, right? So the divergence is the gradient dotted with f. Okay, so we want d dx of cosine z, okay, plus d dy of 3y sine 3z plus d dz of 6x cubed z. Okay. Well, there is nothing in terms of x. There is no x variable in the first one here, so that's just going to be 0. Okay, the second one, there is a y, and so everything else is treated as a constant. So this just becomes 3 sine 3z. Okay, okay, plus this with respect to z, there's a z, so everything else is a constant, so that just becomes 6x squared, or sorry, 6x cubed. Okay, and so this is it. This is just 6x cubed plus 3 sine 3z. Okay, so that's part A. Part B says find the curl, the curl of this thing. Okay, so we're going to set up our matrix ijk, partial with respect to x, partial with respect to y, partial with respect to z. Okay, and then we have cosine z. We have 3y sine 3z and 6x cubed z. Okay. Okay, cross off row and column. We're going to go d dy of 6x cubed z minus d dz of 3y sine 3z. Okay. Minus d dx of 6x cubed z minus d dz of cosine z plus, this is an I and jk here as well. I, j, and then a k. This is going to be d dx of 3y sine 3z minus cosine z, d dy of cosine z. Okay, so d dy of 6x cubed z, that's 0. D dz here, this is going to be 3y. The sign that's going to go to cosine chain rule tells me that's going to be a 3 cosine 3z. So 3 times 3 is 9. So this is a minus 9y cosine 3z I minus, this is d dy of this thing, I believe. No, it's d dx, sorry. It's d dx. Okay, so d dx of this is going to be 12x squared, or sorry, 18x squared z. 18x squared z minus, this is going to be the integral of cosine is negative, or derivative of cosine negative sine. So this is negative sine z j plus plus 3y sine 3z of x. Well, that's just 0. And d dy of cosine z, well, that's just 0. That's 0, 0. Okay. So this is negative 9y cosine 3z I minus 18x squared z minus or plus sine zj. Okay, so that's the curl. Okay, we had, sure, we had 3 and 4, I think. Okay. Let's see, what did 3 say again? Let me pull this up like so. Okay, so 3 says determine whether or not f is conservative. If it is, find a function such that f is equal to the gradient of f. So we want the parent function on that one. Okay. Let's do 3 here. Oh, oops. Okay, so we have f equals 4x cosine y minus y cosine x I plus, is that a negative? I think that's negative 2x squared. Yeah, it is. Negative 2x squared sine y minus sine x j, right? Okay, so we want to know if this thing is conservative. So is dp dy equal to dq dx? So I'm going to take this whole thing and take the partial with respect to y. Okay, so let's take the partial of respect to y. dp dx. Okay, so that's going to be with 3. So p is this guy over here. So this is p and this is, no, I'm doing this backwards. I want dp dy. So this is p and this is q. Okay, so dp dy is equal to dq dx. So dp dy that's going to be 4x times the sine of y, or sorry, it's negative 4x times the sine of y minus cosine x. Okay, so that's dp dy. Okay, dq dx, what is that guy? Well, that's going to be negative 4x sine y minus the cosine of x. Yeah, so that checks. Okay, so it is conservative. Okay. Okay, so we want to know f is equal to the gradient of some f, right? So which is going to be equal to f sub x, right? I plus f sub y j, right? Okay. So we need to find out what's the f sub x. Well, f sub x was equal to the original, right? So, okay, so f sub x is equal to 4x cosine y minus y cosine x. Okay, so now I want to integrate this thing with respect to x. Okay, so this is going to be 2x squared cosine y minus y sine x, right? Okay, plus some c of y, okay, some constant with respect to y, plus k. Because if I take the partial with respect to x, I would get rid of anything that involves just k or just y. Okay, and then some constant. Okay. Okay. So this is my f. This is my original function. No, this is my lowercase f. Okay, my original lowercase f function. Okay, that's by integrating on f sub x. Okay, let's look at f sub y here. F sub y is going to be the second one here, which is going to be, okay, negative 2x squared sine y minus sine x. Okay, so let's integrate on with respect to y of this one. Okay, so we have f is equal to, the integral of sine is negative cosine. So that becomes a negative times a negative, this just becomes 2x squared cosine y minus, this is going to be sine x y, or y sine x, that's cool. Okay, plus something in terms of x and a constant, but there was nothing that came out just in terms of a y or an x, so we can get rid of that. So the original function would be f is equal to 2x squared cosine y minus y sine x plus k. So that would be my parent function. Okay. Okay, so that's number 3. Okay, number 4. It says find a function f and then use it to evaluate this. Okay, so we're going to use the fundamental theorem of line integrals to evaluate this, right? Okay, so, okay, is it conservative? Can we even do that? We'll check to see if the thing is conservative. Looks like it will be. Because if I take the derivatives of those, I think I'm going to get the exact same thing, right? It's going to be, okay, so, yeah, p with respect to, so we've got f is equal to x cubed y to the 4th I plus y to the 3rd x to the 4th j. That's number 4. Okay, so is it conservative? first. Obviously it is, because they're telling us that it is, that we can do this. So, but let's just check it. Let's just check it. dp dy, is that equal to dq dx? Okay, well, take this guy with respect to y. Take the derivative with respect to y. That's going to be 3x cubed y cubed. Take this guy with respect to x. That's going to be the same thing, 3x cubed y cubed. So it is conservative. Okay, so conservative. What does that mean? That means that there exists an f. There exists f. Okay, so that's good to know. Okay, so let's find that f. Okay, let's find out what's the f. So, okay, so the f, let's do this. F is equal to the gradient of f, which is equal to f sub xi plus f sub yj, right? Okay. So now this is f is equal to, okay, so what was f sub x? Well, f sub x would have been equal to x cubed y to the fourth. And what's f sub y? F sub y would be equal to y cubed x to the fourth. Okay. So let's integrate with respect to x here. That's going to be 1/4 x to the fourth y to the fourth plus something with respect to y plus k. Okay, that's going to be f is equal to that. With respect to y, it's going to be basically integrate with respect to y. It's the same thing. So f is equal to 1/4 x to the fourth y to the fourth plus c of x plus k. So like we had before, the c's cancel out. Okay, there isn't anything that involves one that isn't in the other. So this f is equal to 1/4 x to the fourth y to the fourth plus k. Okay, but now they're saying evaluate this thing as a line integral. Okay, so evaluate the line integral along this given curve. Okay, where r of t is equal to this thing here. Okay, so we're going to say where t goes from 0 to 1. Okay, so what do we want? We want the integral of f dot dr along c, but we're going to parameterize this in terms of r of t. Okay. Okay, so so this thing is going to be equal to, okay, 0 to 1 of the gradient of f, little f, of r of t dt. Okay, so which, according to the fundamental theorem of line integrals, is going to be f of r of 1 minus f of r of 0. Okay. Well, what is f of r of 1? Well, we've got to find out, well, what's r of 1? Okay, well, what was r? R was equal to what was r equal to? Some sort of cube roots and square roots. Square root of ti plus 1 plus t cubed j. Okay. Square root of ti plus 1 plus t cubed j, right? Yeah, from 0 to 1. Okay. So plug in 1 for t here. We're going to get the square root of 1 I plus 1 cubed j. So that's going to be j plus 2, or sorry, this is I. So that's I plus 2j, right? So I plus 2j. Okay. Okay, so if I parameterize it, that thing becomes, if I put it in component form, that just becomes 1, 2. This is my x and that's my y. Okay, 1, 2. Okay, r of 0. Okay, this is going to be 0 I plus 1 plus 0 cubed j. So that just equals j. So this is 0, 1. Okay. Okay, so this is my x and that's my y. Okay, so now I need to plug in for f, okay, that we found. Our f was just 1/4 1/4 x to the 4th, y to the 4th. So this is going to be f of r of 1 is going to be equal to 1/4 x to the 4th, which is just 1 to the 4th, plus y to the 4th, or sorry, times y to the 4th, which is 2 to the 4th. Okay, that's going to get 16 divided by 4, that's just 4. Okay. And then what's f of r0 or r0 is going to be equal to 1/4 0 to the 4th times 1 to the 4th, which is 0. So in the end, I'm going to get 4 minus 0, which is 4.
That makes a lot more sense now. Thank you so much.
Okay, question 7. Okay. How many questions will be on the exam? I think there's 10 questions. And what sections will be covered? 16.2 through 16.9, I believe. Omitting 16.6. I don't think 16.6 is on the exam. Okay, number 7. Okay, use Green's theorem to find the work done by the force. Okay, moving a particle from the origin along an x-axis to 0, 1, and then along segment to 1, 0, and then back to the origin. Okay. Okay, so we have f equals x times, what's that? X plus 3y I plus 3xy squared j. Okay. Okay, nice, nice, nice. Okay, so I want to know what's the work done, right? What's the work done for the line integral? Okay. Yeah, use Green's theorem to find the work done by the force. Okay, and we're positively oriented. How do I know I'm positively oriented? Because I'm going around this triangle. And it says I start at the origin, then I move here. So 0, 1, and then I move here. I'll call this step 2. Okay, so step 1 is going from 0 to 1. Step 2 is going from, right, so that's step 2. This is 1, and then we're going step 3 back again. So 3 steps, right? So we're moving along this line integral over this force field, right? However, Green's theorem says that I can change this. Okay, I can change this guy into okay, this thing is equal to p dx plus q dy, okay, which becomes the double integral over the area, call that d, okay, of dq dx minus dp dy dA. So there's my Green's theorem right there. Okay, so we're going to call this P and this Q. Okay, so dq dx is just going to be 3y squared. Okay, dp dy, okay, well, this is just going to be 3x. Okay, so minus 3x. If you were to do dp dy on the first one there, you would just get 3x. Okay, and then this is going to be dy dx, double integral. Okay, and then I want to know, well, I'm going to take a vertical slice here, and then I want to get the double integral over this area here, this domain, with respect to this function here. So, well, I need to know in terms of y, that y is equal to what here? Y is equal to 1 minus x is what that is. Or negative x plus 1. You can think of it as negative x plus 1 if you want. That doesn't matter. Either way. Okay, so what is y going from? Y is going from 0 to negative x plus 1. And then from 0 to 1. Okay. So then we're just going to integrate with respect to y. So these just become y cubed minus 3xy, 0 to negative x plus 1. Plug in my negative x plus 1 in for y. Okay, or 1 minus x cubed minus 3x times 1 minus x. Okay, I don't need to plug in the zeros because it's just going to go to 0. Okay. So now I want to integrate this bad boy from 0 to 1 dx. Now I can multiply it all out if I wanted to. Okay, or I could use some u subs. It really doesn't matter. Okay, either way. So I'm going to multiply this out just to, this is minus 3x minus or plus 3x squared, right? Okay, so maybe I'll break it up like this: 0 to 1, 1 minus x cubed, okay, plus 0 to 1, there's a dx there, dx, plus 0 to 1 of negative 3x plus 3x squared dx. Okay, so get that going on there. Okay. Okay. So now we're going to do a u sub on this. U equals 1 minus x. Du equals negative dx. So negative du is equal to dx. Okay, so this is going to be I don't know. You could redo the limits of integration if you really wanted to. It's going to get reversed though. This is going to be 1 and 0. That's going to make this a negative u cubed du. If I were to reverse the limits, I'd get rid of that negative. So this is just u to the 4th over 4, right? So u to the 4th over 4, which is evaluate from 0 to 1 just as 1. I'm sorry. Yeah, evaluate from 0 to 1 is just 1/4. So positive 1/4 for that. Okay, what about over here? Over here, we're going to get negative 3/2 x squared plus x to the 3rd, right? Okay, evaluate this from 0 to 1. Plug in the 1, that's negative 3/2 plus 1. So that's negative 1/2. Okay, so I'm going to take 1/4 and subtract off 1/2, which is negative 1/4. Okay. So the work done is negative 1/4, which means that it's going against whatever the flow would be. Maybe the flow is going like this. Who knows? You know. Oops. Let's go back. Okay, we don't know what the force field is doing, but you know, maybe there's some sort of force field that is flowing against, right? Maybe it's positive in this direction, but then we're kind of moving against in this direction, and then against in this direction. And so we're moving against the flow of water, say it's water, we're pushing it against, and so work ends up being negative. Okay. Okay, number 2. Yeah, sure. Okay, number 2, you can actually do 2 different ways. There's an easy way and a hard way. I don't know which way you want to see done. So do you want to see the easy way or do you want to see the hard way? I can do both for you. Okay. So whatever I think is most educational. Okay. Both. Okay, let's see. So the hard way is to say that we have f equals 30xi plus 15 times 2y plus 1 j, right? And then we have r of t is equaling to t minus sine I, or sorry, t minus sine t I plus 1 minus cosine t j when t goes from 0 to 2 pi. Okay. Okay, so they're saying what? They want a line integral on this thing? Okay, oh, find the work done, yeah. Moving object along. So this is f dot dr. Okay, so f dot dr. So the work equal to the line integral f dot dr, which is equal to, if I parameterize this thing, it's going to be along C of f of r of t dotted with r prime of t dt, right? That's what that guy is. Okay. So then, well, f of r of t, okay. We know what x is and we know what y is. So, yeah, this is my x, right? And this is my y. Okay. So x is equal to t minus sine t and y is equal to 1 minus cosine t. So I could just plug that directly in. Okay. So this is going to be 30 times t minus sine t. Okay. I plus 15 times 2 times 1 minus cosine t plus 1 j. I want to dot that with r prime of t. Well, I don't know what r prime of t is. I have to find that. What is r prime of t? R prime of t is going to be equal to 1 minus cosine t I plus, that's 0. Cosine goes to, this is just plus sine t of j, sine tj. Okay. Looks good. So that's going to go over here. Okay. So that's 1 minus cosine t I plus sine tj. Okay. Yep, sine tj, and then that's just dt. We've got to dot this thing, though, right? So it's dotted with this guy, dotted with this thing. Okay, so we got to do x's with x's and y's with y's. So this is going to be, okay, and then we already know what c is at this point. C is it's in terms of t, and the limits for t go from 0 to 2 pi, right? So we do know what our limit is there, 0 to 2 pi. Okay, so now we're gonna dot this thing. This is going to be 0 to 2 pi of 30 times t minus sine t times 1 minus cosine t. Okay. Plus 15, maybe I'll distribute the 15, I don't know. Let's see. I'll just do 15 sine t times 2. I could distribute the 2 as well, but whatever. 2 times 1 minus cosine t plus 1. There's a parenthesis there. Okay, plus 1. Okay. Yep. Okay. Okay. Yeah, dt. Okay, so let's see what we get here. So when I multiply the first one all out, I'm going to get 30 t minus 30 t, yeah, minus 30 t cosine t. Okay, minus 30 sine t, and then plus 30 sine t cosine t, right? Okay. The second one here, this will be distributed to 2. 2 plus 1 is 3. Is that right? 2, 3. Yeah. So this is going to be plus 15 sine t, that's 30. So 30 sine t. Okay. Okay. Plus, that's 2, right? 2 and then 2, that's minus 30 sine t cosine t. Okay, so I just distributed the 2 here. And then plus 15 sine t. So some nice things happen. Okay, this guy cancels with this guy. Okay, and this guy cancels with this guy. So I'm just left with, and there's the dt here, but whatever. 0 to 2 pi. This is 30t minus 30t cosine t plus 15 sine t. Okay, nice. Yep. Okay, and then dt. Okay, so I'm going to rearrange this. I'm going to do 30t plus 15 sine t minus the integral of 0 to 2 pi, 0 to 2 pi dt. And then this is going to be minus 30 t cosine t. Okay. Okay, why? Because these are the one in the front here. Those are the easy integrals, right? Those are the easy ones. Okay, and the one over here, this is integration by parts. Okay, so this is just going to be what, 15t squared? Okay, plus or minus 15 cosine t from 0 to 2 pi. Okay, so this is going to be 30 pi squared. No, this is 60 pi squared because it's 15 times 2 pi squared. So that's 60 pi squared. Okay. 60 pi squared. Okay. Nice, nice, nice. Okay, and then this guy, plug this 2 pi in, that becomes 1. So that's minus 15. And then if you plug in 0, that's still 1. So it's minus 15 minus 15. It's just, it's a minus 15 minus a minus 15, which goes away, cancels. Okay, so now let's do this thing by parts here. Okay, so u is equal to t. Okay, dv is equal to cosine t. Okay, and you can pull out the 30 if you want. Maybe I'll pull out the 30. Okay, so this is going to be 60 pi squared minus 30 times, okay, this is du is equal to dt, and this is going to be sine t, right? V is equal to sine t. So uv and v du. Okay, so this is 30 times uv, this is t sine t, minus the integral, okay, 0 to 2 pi, of sine t dt. Okay. It's nice. Okay, so plug in here, if I plug in the sine of 2 pi, I get 0. And if I plug in the sine of 0, I get 0. So this thing goes to 0. That thing goes to 0. It's nice. Okay, so we got a minus times a minus, that's a positive. So 60 pi squared plus 30. Integrate this thing, right? So that's just going to be negative cosine. Okay, 30 times the negative cosine t, right, from 0 to 2 pi, and we come out with the kind of the same arrangement that we had before, where if you plug in a 2 pi, it goes to 1, and if you plug in a 0, it goes to 1. So we're going to be subtracting the exact same thing. We're going to take a negative 30 and subtract off a negative 30, which goes to 0. So the whole thing goes to 0 except for this piece here. Okay, that's the hard way to do this. Okay, does anybody know the easy way to do this? Okay. Yeah, fundamental theorem of line integrals. That's the easy way. I can do the same problem in like 3 lines. Okay, using the fundamental theorem of line integrals. Okay, now what do I need to know in order to use the fundamental theorem of line integrals? What do I need to know in order to use the fundamental theorem of line integrals? What does it have to be? What does the function have to be?
Does it have to be conservative?
It has to be conservative. Thank you, Ismene. It has to be conservative. Is this function conservative? Is f equal to 30xi plus 15 times 2y plus 1j, is that conservative? Well, let's call this p. Let's call this q. What happens when I do dp dy? What does that equal? 0. What's dq dy? Dx? 0, because this one doesn't have a y, and this p doesn't have a y, and q doesn't have an x. Right? So is it conservative? Is dp dy equal to dq dx? Yes, check. It's conservative. Well, that's kind of nice. Because now what does this tell me? It tells me that I can take this guy and I can take him and I can rewrite him, okay, as the parent function, right? The parent function evaluated R of B minus the parent function evaluated R of A, okay? There, okay, right? So for some A and B, well, we already know what the A and B's are, okay? Because we're gonna, our parent parameter is T in this case. And T goes from 0 to pi over 2. So since T goes from 0 to pi over 2, or sorry, not pi over 2, 2 pi. Okay, 0 to 2 pi. We know this is f of R of 2 pi, not to be confused with f of R of 2 pi. Forget it. Okay, minus f of R of 0. Okay, so now we just have to plug it in, right? First we have to find our parent function though, but that's not too hard in this case. Okay, let's see what our parent function would be. Okay, so f is equal to f sub x I plus I plus f sub yj, right? Okay, so what would f sub x be? F sub x would be equal to 30x. Okay, so, right? Okay, so what would f be? What would little f be? Little f, if I integrated that thing, that would be 15x squared, right? Okay, plus some constant of y plus k. Okay, so what about this guy over here? What was the y value? The y value, that's, I'm just gonna distribute. I'm gonna call it 30y plus 15. Okay, that was for j. Now what's that guy gonna be? The f. Okay, let's integrate this with respect to y. Well, that just becomes 15y squared plus c of x plus k. Oh, okay. Is that right? 30y? Let me just make sure that I'm doing this right. Plus 15. I think I messed up somewhere. 15 plus 2y plus 1, right? No, that's 30. Oh, I forgot the 15y. Yeah. Plus this is 15y. I forgot this guy over here. Okay, 15y plus c of x plus k. Okay, so what is my c of x? And what is my c of y? Well, my c of y is this thing. And what's my c of x? My c of x is this thing here. So what's my parent function? My parent function is going to be f equals 15x squared plus 15y squared plus 15y plus k. Nice. So we now have found our parent function. Okay, so now all I have to do is plug in an f of r of 2 pi minus f of r of 0, and I should have my answer. Okay, so what is r of 2 pi though? So let's go back to r. What was r? R was equal to t minus sine ti plus 1 minus cosine tj. Okay, where t goes from 0 to t to 2 pi. Okay, nice. Okay, so plug in 2 pi here. So this is going to be what? 2 pi minus the sine of 2 pi, which is 0, plus 1 minus the cosine of 2 pi, which is negative 1, right? So that's going to be think about this for a second. So minus, so this is 2 pi I plus, this is the cosine of 2 pi r of 2 pi is 2 pi and what? Cosine of 2 pi is -1. Okay, just put in a 2 here. So plus 2, I think. Okay, so that's j. Okay, so we'll go 2 pi 2. Okay, and then that's r of equals r of 2 pi. Okay, and then what's r of 0? Well, that's just 0. Sine of 0 is 0. Cosine of 0 is 1, so the whole thing goes to 0. So this whole thing, okay, so r of 2 pi is equal to this. R of 0 is equal to 0 minus the sine of 0, I, plus the 1 minus the cosine of 0. Okay, j, so that's just 0, 0, 0, 0. Boom, okay. 0, 0 for r of 0. Okay, so now, what are we doing? Well, we're going to plug in. Okay, so we want f evaluated at 2 pi, f evaluated at r of 2 pi. Okay. Minus f evaluated r of 0. Okay, so what is f again? What was our f, our parent function? Parent function we found out to be this thing here. Okay, so f is equal to I feel like I screwed up somehow. Because it should come out to 0. Why is it not coming out to 0? It says in my notes that r of 2 pi is equal to 2 pi and 0. But I'm getting a 2 here. Oh. Minus cosine. Oh, well, let's just continue and we'll see if I can see my error. Okay. So what was f? F was this thing, right? So 15x. So for this guy, it's x is.
I don't know if this helps, but looking at it, I think it's possible that the r of 2 pi is 2 pi plus 0, because when you're looking at the like 1 minus cosine of t and then 1 minus cosine of 2 pi, would that not be 1 minus 1?
Oh, you're right. Thank you. I was thinking of pi. Thank you. Yes. That's where I made the mistake. Yeah. Cosine of 2 pi is 1. 1 minus 1 is 0. Perfect. Okay, yes. I was like, why is that? That should be 0. Okay, thank you. Thank you so much. Yeah, 1 minus cosine 2 pi is 0. Thank you. I don't know why I was thinking it was cosine of pi. But I had that in my brain for some reason. Okay, good. We're on the right track. Okay, so now when I plug this in, it becomes f of 15 times 2 pi squared plus 15 times 0 squared plus 15 times 0, right, plus k. So that's what this is. 15 of that, right? That's the first thing. Okay, minus the second one, which is 15 times 0 squared. This whole thing's just going to go to 0, right? 0 squared plus 15 times 0 squared plus 15 times 0 plus k. Okay, so this whole thing just becomes, the k's are going to cancel. K minus k, 0, 0, 0, 0, 0. The only thing that survives is 60 pi squared. So that's the easier way to do that. With the, there's no integration by parts involved in that. So, but this does kind of is nice. It kind of proves, you know, that you can do the problems two different ways. Right? Like it hopefully it connects the pieces, right? You're just like, oh, the thing that we learned about conservative over here connects with the thing that we learned about getting a line integral using the derivative over here. So they'll kind of tie together. Which is nice. Okay, number 10. Ooh, nice. I like number 10. Number 10 is a good problem. Okay, use Stokes's theorem to evaluate this guy. Okay, is the curve of the intersection of the hyperbolic paraboloid z equals y squared minus x squared, and the cylinder x squared plus y squared equals 25, oriented counterclockwise is viewed from above. Okay, so positive orientation basically, right? Counterclockwise is positive orientation. Okay, so the intersection of these two things, right? Okay, and this paraboloid, which is 0, 0, 0, so that's kind of nice. Okay, it's a parabola. Okay, so hyperbolic paraboloid. That's a saddle point, actually. That's a saddle. Hyperbolic paraboloid. It's kind of cool. Okay, so we need our f, which is this thing right here. Okay. Do I have room to do it here? Maybe I'll do it. I don't know. I'll go back to the paper. Okay, so we have z is equal to y squared minus x squared. And we have x squared plus y squared equals 25. So, so we have this surface, okay? We have this cylinder out here at 5, right? So we've got this cylinder here, okay? It goes down. And then we have this hyperbolic paraboloid, which is looking like, oops, I'll do that into a color. Okay, our hyperbolic paraboloid, which is sitting like this, and then like this, oops, and then like this as well. Okay. And we want to know, well, what are our boundaries here? Okay, the curve is the intersection of the hyperbolic paraboloid and of the cylinder. Okay. Okay. So we're going to use Stokes's theorem on this one. Okay, so we're going to say that okay, so this is S. Well, that's going to be A, dA there, but we'll get to that in a little bit. Okay, so Stokes' theorem says that we can rewrite this f dot dr, okay, as the surface over the surface of the curl of f dot ds, right? There's a diagram in the back here, by the way. has all these formulas. So I'm going to try using the right formula. Yeah, that's right. Okay. Big S. Good. Okay. So let's find the curl of f in this thing. Well, first, what's f? F is equal to 6yx squared I plus 2x cubed j plus 6xy k. Good, good, good. Okay, so let's find the curl of f. Curl of f is equal to ijk ddx dy dz. This is 6yx squared. This is 2x cubed, and this is 6xy. Okay, so I'm just going to do the partials in my head, if that's okay with you. I already did one where I had to write it all out. I'm just going to do the partials in my head. d dy of 6xy is 6x. D dz of 2x cubed is 0. Okay, d dx of 6xy is 6y. D dz of this guy, 6yx squared, is 0. Okay, ddx of 2x cubed, that's 6x squared. And ddy of 6yx squared is 6x squared. So that goes to 0. That's nice. Okay, so that goes to 0. So this is going to be 6xi minus 6yj. Okay. Okay. Okay, so now we can have this thing be referenced to I want to think about this for a second. Okay, so now I know that I can rewrite this. Okay. Yeah, C f dot dr, right? Okay, over S. Okay, over the surface, right? Over the surface S of, and we said, yeah, put the pieces, all the pieces together. For Stokes theorem. Okay, so we want to find C. Okay, C is the intersection of these two. Okay, the projection of D onto S of S on the xy plane is the disk. X squared plus y squared is less than 5, or less than 25. So we have this disk here. Okay, x squared plus y squared is less than or equal to 25. Okay. So that's over that S surface there. Okay. And so we know that the curl of f dot ds is equal to this d, okay, the projection of S onto D of negative P dg dx minus Q dg dy plus R dA. Okay. This is similar to one that we did in class. Okay. Where P, Q, and R all come from the curl, right? So P, Q, and R, this is P, and this is Q. Okay, P, Q, and R all come from the curl, and G, okay, what's G? dg comes to us from Z. Z is equal to y squared minus x squared. And we can call that G of xy. Okay, so that's G of xy. Okay, so plugging all the pieces in, we're going to have this double integral of negative P, that's negative 6x. Okay, dg dx. Well, what's dg dx? That's negative 2x. Okay, times negative 2x. Okay, dg dx is negative 2x. Right? What's dg dy? That's just 2y. Okay, minus q. Q is negative 6y. And then dg dy is 2y. Okay, dA. Okay, so what is this going to become? This is going to become positive 12x squared and positive 12y squared, I believe. Yep. Okay, and this is double integral d over dA. Okay, so now, well, this is kind of nice. This is 12 times x squared plus y squared. And what's really nice is we have a circular region, which means that I'm going to go to polar coordinates on this. Because we have this region here is a circle, D. This is D now. This here is D, which is just a circle. Okay, this is the region, and then there's going to be an intersection here of these, of this, right, with respect to here and with respect to here. Okay, so we have these surfaces. Okay, but the projection of those is on that disk. So then I'm just going to say, well, this is 12 times, okay, 12. This is r squared, right? This is r squared. R squared, r dr d theta. Okay, and what does r go from? It goes from 0 to 5. That's the radius. And theta goes from 0 to 2 pi. Okay, nice. Okay, so this is really, oops, I already have the 12 outside, sorry. This is really r cubed. Well, what's the integral of r cubed? That's 1/4 r to the 4th, 0 to 5. So this is just 5 to the 4th over 4, right? Which is 625 over 4. And then I have to integrate that with respect to theta, from 0 to 2 pi, d theta, with a 12 on the outside. Okay, so this is going to be 625 theta, 625 over 4 theta, put in the 2 pi. That's going to cancel with one of the 4 on the bottom. So this is 625 over 2 pi. And then multiply that whole thing by 12. So this just becomes 6 times 625 pi, which ends up being 3750 pi. Boom, there we go. So that's number 10. Sure. Okay, well, I honestly think you guys can handle the rest on your own. What do we got going on? So exam on Wednesday, right? I mean, the rest are not too bad. They're pretty simple, actually. Okay. Those were the hard ones that we went over today on the review. I'll see you on Wednesday then, okay?
Bye. Thank you.
You're welcome.
Thank you, Professor.
Yeah, and I'll post this review on YouTube right now as well.